So in this lesson, you guys are going to learn all about these three really special trig ratios applied for right triangles. And in order to find these ratios, all you're going to be doing is what you did on this page here. Now, if you go to the next page here, you'll actually notice if you read this direction that the directions don't really make much sense. What I actually meant in the direction was this. Using these angles specified here, I want you to label the opposite hypotenuse and find the ratio between those two. So if you know what I'm talking about, feel free to pause this video and actually try it. But if you want a little bit more guidance, I will do some problems and then I'll just give you guys the rest of the answers. So this will be both a introductory video as well as the answer key to this packet. So angle A is right over here. If I'm starting at angle A, then this is my opposite, this is my adjacent, and this is my hypotenuse, which again is either the longest leg or the leg that is facing the 90-degree angle. So opposite would just be 12 over 8, 13. For letter B, starting angle B, this time the opposite is 5, the adjacent is 12, and the hypotenuse is 13. So this opposite over adjacent, or hypotenuse, is 5 divided by 13. Angle A should just be 12 over 13, which is not showing up. I lied to you. No, it's not. It's 5 over 13. And number 4, adjacent to B is 12 over 13. Okay. Let me actually write the answers here. What was it? Opposite was 12 over 13. For number 5, describe the relationship between the ratios angle A and angle B. Well, without having to write it down or just kind of saying it, the ratios here are really clear. These two are equal to each other, and these two are equal to each other, which is going to be kind of a common pattern we're going to see here. So you can use that pattern to help you out with some of these problems, but that's generally what I wanted you guys to see. So let theta be an acute angle in a right triangle ABC. Then you can identify 3 trig ratios. But just real quickly, if you guys remember, acute literally means less than 90 degrees. Hope you guys remember that. So these are your 3 right triangles, or your 3 ratios. You have sine of theta is equal to opposite over the hypotenuse. You have cosine of theta, which is equal to the adjacent over the hypotenuse. And you have tangent of theta, which is equal to the opposite over the adjacent. This should sound familiar. I know you guys haven't done an extensive review of trigonometry, but you have looked at these 3 ratios in geometry. And if you guys remember the acronym for memorizing each of these 3 formulas here, it is simply SO, CA, TOA. SO here meaning sine of the angle theta is equal to the opposite of hypotenuse. Cosine of the angle theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. So SOHCAHTOA, TOA, please remember that. In these examples, I want you guys to find sine, cosine, and tangent. I feel confident you guys can try it on your own, but if you don't feel confident, feel free to watch how I'm about to write the answers. But when you are ready, unpause the video and compare your work with what I'm about to write. So again, SOHCAHTOA. Sine of the angle theta is equal to opposite over hypotenuse. Cosine of the angle theta is 36 over 39. Oh, you guys should simplify all these, by the way. I'm sorry, I forgot about that. And tangent of theta should just be which is 5 over 12? Yes, okay. The next one, oops, how do you do this? Oh, whoa. Now, these are really great questions. These are actually questions on the park, which again, you guys really don't have to worry about. Lucky you guys. These are questions that are aligned to the park, but they're really good questions. The park actually has a lot of good questions. It's just they're very oddly phrased sometimes, and they're very difficult. But I love these questions because they really go into the full breadth of what you can do with SOHCAHTOA, minus the application portion. This is what I want you guys to do. Fill in this table basically. So literally, these shouldn't be capitalized, sine, cosine, tangent. What I want you guys to write is this. I'll have to write it really small, but sine of 33.7 degrees is equal to the opposite over the hypotenuse, 2 over root 13. So 2 over root 13. Cosine is, starting from this angle, 33 degrees, is 3 over root 13, and tangent is 2/3. So now try for 56.3 degrees. Once you're ready, unpause and compare your answers. You're going to do the exact same thing down here, but it's going to be a bit easier. Oh, also one more quick comment. If you actually noticed, if you guys remembered, you should not leave yours, for example, like this one. You really shouldn't leave a root on the bottom, but it really doesn't matter here because, okay. So let me backtrack. Let me explain to you guys why people don't like the root on the bottom. People don't like the root on the bottom because it's harder to calculate with when you're doing it by hand. So when you're doing it by hand, trying to find square root of 2 divided by square root of 13 is actually really difficult versus something like this, which is a lot easier to do. That is when you do it by hand. However, we've gotten to the point in an age where if you want to find the decimal equivalent of this, you are just plugging it into your calculator. So at this point forward, we actually don't really mind our roots being on the bottom, but do know how to change it just in case your professor decides to be a nitpicker, because I mean, he's your professor. You can't really argue with that. But again, in this class, especially for this lesson, I don't care if the root's on the bottom. It really makes no difference at this point. At this point of 2015 onward, it really does not make a difference. Same thing here. Again, pause the video, try it, but I will give you guys the answers. Ooh, no. Oh. I hope you guys are noticing a pattern. There's a really, really nice pattern here happening. It's kind of cool. Same thing. Alright, let's do it. What am I doing? Alright, I'm doing this. I like this question a lot. If you guys know the pattern, you guys can definitely answer it, but let me read the directions. Tamer did not finish completing the table below for a diagram similar to a previous problem, so the teacher had the board where P was a measure of angle P and Q was a measure of angle Q. Use any patterns you noticed from questions 2 to 5 to complete the table for Tanner. What I mean by 2 to 5, I mean these questions here. I meant the previous question. In case you guys didn't know the pattern is simply this. When you're dealing with the opposite angle, so when you're going from P to Q, your answer for sine and cosine flip. So this sine of Q is actually going to equal to this little piece over here. And this cosine of P here, or Q, sorry, is going to equal to this 11 over root 157. And the tangent of Q is just going to be itself flipped over. You know, not the most urgent pattern, but pretty cool that it's happening. I like that. This is basically your homework, guys, from this page onward. So if you guys get them done, I'd really appreciate it. Again, because it's so new and because I'm not currently present, I will actually write the answer down on this video, so feel free to watch it when you're confused or if you want to correct your work. But please don't just copy this stuff down into your notebook. I'm going to trust you guys on this because I will give you guys a test on this very soon, quiz on this very soon. So just be prepared for that. Okay, let's do it. What am I doing? Oh yeah, angle S, angle T. Okay, here's S. Which values are equal? Cosine of S is equal to sine of T. Sine of S is equal to cosine of T. How are tan S and tan T related? They are inverses. Or reciprocals. Actually, they are reciprocals. Would be better answers. The word why we're not doing inverses, because inverses also imply opposite signs, whereas reciprocal is just everything flipped. So it's a better choice of words there. Number 2. If u and v are the measure of complementary angles such that sine of u is equal to 2 over 3 and tangent of v is root 21 over 2, label the sides and angles of the right triangle. The diagram below with the possible side length. Okay, so quick comment. Complementary, if you guys remember, just means two angles that add up to 90. So complementary here means that whatever u and v is has to add up to 90 degrees. Just reminding you guys, because I know geometry was a very long time ago. Okay, I'm going to use this. Sine of u is equal to 2 over 3. But if you guys remember, sine was opposite over hypotenuse. So, starting from angle u, which is over here, the opposite is 2, the adjacent is 3, so that means that means in order to find this, you will just do the Pythagorean theorem from here. Where did the root 41 come from? 2 squared plus b squared equals 9 squared, so that's 4 plus b squared equals 81. Oh, okay, I see where the root, okay, I see where that came from. That's 77. No, I don't see where this came from. Where did that come from? Oh, no, that should be 3 squared. That should be a 9. Where did root 21 come from? That doesn't have to a right triangle. That has to be a typo. I must have messed up. I messed up somewhere. That definitely should not be a root 21. That should be a root 5. That should be a root 5. For those confused, sorry, I didn't mean to confuse you guys. I didn't mean to confuse myself. For those confused, let me explain what I was trying to do. I think you guys understand. You guys can use Pythagorean theorem here to find the third leg. So that should be square root of 5. That is not square root of 5, obviously. That's square root of 21. If you actually apply tangent here, tangent is opposite over adjacent, starting from angle V. So opposite here would have been this square root of 5. But no way square root of 5 and square root of 21 will ever be equal. So that has to be in typo. That was my fault. Clearly that was my fault. Sorry. But I hope you guys understood it though, because this is a really good skill to know for trigonometry. For geometry. No, this one's easy. You guys can do this one without me talking. 2 root 5 over 6. I simplify this, which becomes root 5 over 3. Over 6, 2/3. Again, simplify. Tangent should just be root 5 over 2. That's a 5. Angle B should be 4 over 6, which is 2/3. And this one should be this one should be 6 over 2 root 5, which should be 3 over root 5. And the last piece should just be 2 over root 5. Here you can label the sides. I give you a whole lot of information in this table, but you really don't need all this information. But let's choose sine of alpha. Oh, in case I'm not very clear, these are Greek letters. They're lowercase Greek letters for alpha and beta. So when I'm reading this, I'm reading sine of alpha, and they look like little fishes or little ribbons. So just, heads up. Again, this is opposite over hypotenuse. So you just can label that. Here's alpha, opposite is 4, hypotenuse is 2 root 10. And if you guys want to find the third leg here, you guys can either use cosine or tangent, or you guys can use Pythagorean theorem. Let's use cosine of alpha though, because I don't feel like using Pythagorean theorem. I'm very lazy. That's adjacent over hypotenuse. So starting from angle alpha, your adjacent should be this, 2 root 6, and your hypotenuse should be 2 root 5, or 2 root 10, which it is. So that is your triangle. Okay, the answer for this, write it over here, and the last one's flipped. On your paper, please don't do this. Actually, write it out. I'm just very tired right now. Triangle, is that a 6? That's a 6. That is a really bad 6. Okay, right triangle to fill in the rest. You guys should realize, before you even begin, that this right triangle is actually incomplete. In order to complete it, you guys use Pythagorean theorem. 2 squared plus 6 squared. That's 40 equals c squared. So that should be square root of 40. Sine of alpha, cosine of alpha, and this thing, which is just 3. That should be a 40. Why did I put 60? That should be a 40. Oh, right, I forgot about this question. Sine of alpha, again, same thing. 3 root 6 over 9. Simplify that, becomes root 6 over 3. Cosine of alpha should be 9. No, I lied to you. Should be 3 root 3 over 9, which is root 3 over 3. And tangent should just be root 6 over root 3. Beta should be 3 root 3 over 9, which is just root 3 over 3. Cosine of beta should just be root 6 over 3, which is the answer from here. And the last one should just be root 3 divided by root 6. You guys can actually simplify this. This actually becomes root 2, and this actually becomes 1 over root 2. Rewrite each in the simplest terms. I already kind of did that. We already kind of did that up here, so you guys don't have to write that twice. Draw label side ratio. Oh, they're basically saying in this direction here, simplify this triangle down. So take out a greatest common factor. I'll let you guys deal with that part. But that's really all there is to this. I should have given you guys also an inverse related one. The inverse is done the exact same way, which I don't have with me right now. So feel free to ask me questions when I see you guys again on Thursday. Okay.